Sometimes we might want sounds to move in a particular direction relative to the player. For example, bats might fly towards the player, or an aircraft might fly across the world from left to right. We'll look at how to use vectors to move sounds. Bookmark key 6 takes us to the first cave in the demonstration level. And in this cave, there's a number of creatures that are quite interested in the player, and they keep flying towards you whilst you're inside the first and second caves. And you'll notice that whatever direction I'm facing as a player, they'll always fly towards me. The creature itself belongs to a blueprint called Sweep Through Sound, but that blueprint is actually spawned by another blueprint called the Sweep Through Launcher, which is just here in the level. In the details panel, we can assign a sound. This sound cue actually has the attenuation settings defined within it, but we could override that with an attenuation settings asset if we chose to. We can set the speed, whether or not to visualize, and we've got these X, Y, Z, min and max settings that will define how far away from the player the sound is spawned. And we've got a minimum spawn time, so in this case, no sooner than 2 seconds, and a maximum spawn time, so no longer than 5 seconds. So let's have a look at the Sweep Through Launcher. So what this blueprint does is set a random timer using the minimum and maximum times defined by the public variables in the blueprint. At this random time, the function spawn sweeper is called, and this executes this custom event here, and this spawns the other blueprint. We assign some settings to it: the spawn transform location, the spawn transform rotation, the sound itself, the attenuation settings, and the speed. Then we go back to the timer to generate a new random float in range to set the time before the next blueprint is spawned. To set the location where this is spawned, we get the forward, right, and up vectors of the player so that the spawn point will be relative to the player's rotation, and then add the random min and max values to this. We also find the look at rotation, so what the rotation of this actor will need to be in order to be facing in the direction of the player. Now we could put a large collision component within this blueprint and start and stop timer using that, but in this case we wanted it to be active throughout the whole cave system, which might not be a uniform shape. So what we're doing is we're using triggers in the level. So here, this first trigger, we find that in the blueprint. We can see that we've got a reference to this Sweep Through Launcher, and we're using the trigger to start the blueprint. And if we come back out across this trigger, then we stop the blueprint. And we've put another trigger at the other end of the cave system. Here, as we exit, this is behind the waterfall. And again, similarly, that toggles the blueprint to stop or to start. Obviously, you need to be careful with these kind of flip-flop systems to make sure that the player always starts on the correct side of the trigger. Otherwise, everything will be working in reverse. So let's have a look at the blueprint actor that's actually spawned here by this launcher. This is the Sweep Through Sound. So this system is started by this event begin play node. This can be a little confusing. Often when we're using this, a blueprint already exists within the game level. So effectively, yes, this is an event that triggers when play begins. But what it actually is an event that triggers when play begins for this actor. In this case, the actor doesn't exist until spawned by the Sweep Through Launcher blueprint. So event begin play only fires off when this actor is actually spawned into the world. So here we take the sound and the attenuation that's been defined in the Sweep Through Launcher here, and we apply those to the audio component, then we play the audio component. The blueprint has been spawned at a randomized distance from the player, and its rotation has been set so that it's facing towards the player. So we use an event tick to multiply the forward vector by our factor speed, and this means that every frame the blueprint will be given a new position. therefore moving it towards the player at a speed defined by that appropriately named variable speed. Here we've got an event bound to on audio finish. So when the sound finishes playing, the tick is switched off, so it stops moving, and then the actor is destroyed. We can take a look at this print string that's going to print that vector to screen to see how this tick is updating those values. So we'll start back at the entrance to cave 1 again, and we're going to walk through that trigger that starts the whole system. So this blueprint launcher has got the player's location. It's added those min-max values to it to spawn the sweeping blueprint at that distance from the player. It's got the lookout rotation, so it's also spawning the blueprint rotated correctly to face towards the player. And then its forward vector is being updated every tick by that speed factor, which then updates its new position and moves it towards the player. We should note that the sweep through launcher blueprint sets the location and rotation of the sweep through sound blueprint at the moment that it's spawned. So it's spawned at a given distance from the player and rotated to be facing the player. It'll then update its forward vector every tick and will move along this trajectory. Meanwhile, of course, the player may have moved. If you want a system that constantly adjusts the trajectory, then you'd need to get the sweep through sound blueprint to constantly check the lookout rotation between itself and the player. Whether you want this or not will depend on several factors: how far away from the player the sound object will spawn, how long it takes to reach them, and how important it is to the particular circumstances of your game. We've seen how using vectors can enable you to spawn sounds with trajectories that are relative to the player. We've also looked at how one blueprint actor can spawn another. In this example, we've just got the sound to essentially look at the player and then move towards them in a straight line. But if you brush up on your trigonometry, then you could create all kinds of different movement paths.